All right, here's an example of a decomposition of something by a first order reaction. Um, we have a couple of different concentrations and times, and then down here it's asking what is the initial concentration of PCl5 in part C. So before we jump in, I just want to sketch out some things here. So at time equals 0, the concentration is not known. And as this substance decomposes, you can see that there's 0.0384 molar at time 250 seconds. Okay. And at 400 seconds, the concentration is 0.0150 molarity. So we'll use different times here when we do some of these calculations. So for part A, we want to determine the rate constant. And so what you want to do is use the integrated rate equation, which has this form: natural log of initial amount minus natural log of final amount is equal to K times time. And so we want the rate constant. So obviously we don't know the concentration up here, so we want to use these two data. And so the time difference between these we'll figure out, and we'll plug these in, okay? So this is going to be the initial concentration, 0.0384. This is going to be the final concentration, 0.0150, right? The concentration drops. So we want K here, so I'm just going to go ahead and solve. Well, let's just go ahead and plug things in. So the natural log of initial concentration minus the natural log of the final concentration is equal to K times time, and the time here is 400 minus 250, or if you want to do that in your head or on a calculator, that's fine, and plug that in. So to calculate K here, well, the left-hand side becomes 0.940, and that's equal to K times 150 seconds. And so K here is equal to 6.27 times 10 to the minus 3. Okay, and the units here are per second. Okay, so that's the rate constant. Now, in part B, we just do some side calculation here. They want to know what is the half-life. So we use the half-life formula. T1/2 is equal to natural log of 2 over K. And so we plug this in. Natural log of 2 over 6.27 times 10 to the minus 3. And you can see 1 over reciprocal seconds gives you seconds. And the answer here is about 110.5 or 111 seconds. Okay, so that's the half-life. Now, we're not going to use that in subsequent calculations. I think it's good practice just to be able to calculate the half-life, right? So 111 seconds for this problem. Now, part C becomes a little tricky because it says, what is the initial concentration of PCl5? So we're actually wanting to know what this initial concentration is right at the beginning of the experiment, not this 250 seconds after it started decomposing. So to do this, we again start with this integrated rate equation right here. And we want to plug in some values here. So let's block off some space here. So for part C, we want to think about what the final concentration is. Now we could use either of these two data, but I've decided to use this concentration here for the final concentration. So A at time t, I'm calling time t 250 seconds here. The concentration is 0.0384 0.84, right? And the concentration initially is unknown. That's what we're trying to find. And the time is 250 seconds between the initial unknown concentration and this value here. So that's 250 seconds. Okay. Now K, remember, we've calculated that from part A. I'm just going to rewrite it up here, down here, I mean, 10 to minus 3. All right, and again, we just use the integrated rate equation to calculate those values. So let's start over here. We have the natural log of the initial amount minus the natural log of the final amount is equal to KT. And let's go ahead and solve for the initial amount, which is what we want. So add natural log of A time t to both sides. And now we sort of just plug and chug. So K is 6. Let me leave a little room here. 6.27 times 10 to the minus 3. That's reciprocal seconds. And the experiment's 250 seconds between those two data. And we want to add the natural log of the concentration, 0.0389. And so if you plug that all into your calculator, you should get negative 1.69. Okay, and that's equal to the natural log of the initial amount. So that's not our answer yet. Take the anti-log to that. Basically, e to the negative 1.69 is equal to 0.184 molarity. So that's the actual concentration at time equals 0. That's that question mark right here that we're trying to find. Okay, so go ahead and box that answer up here. So that's how you work this problem.